Alright, this video is about Earth's motion, answering the essential question, what are the effects of the Earth's two types of motion? So we are looking at two different examples of the way the Earth moves. The first one, take the example of a pig roasting over a fire. Now if you turn this lever or crank, the pig will spin or rotate along this axis, and it'll cook evenly. Now the Earth does something similar. When we say the word rotation, we are talking about the spin of the Earth. Around its axis, this rotation takes 24 hours and is responsible for day and night. So when we look at the Earth's axis, this axis is an imaginary line that runs through the north and south poles. Now this axis is also tilted at an angle of 23.5 degrees. So it's not exactly up and down, it is tilted slightly 23.5 degrees. And this is the axis that the Earth spins around. So, looking at this image, here we're looking at the Earth from above. This red dot marks the North Pole. So let's look at what's familiar. Okay, here's North America. We can barely see the Gulf of Mexico, Florida. So we in Dallas are about here. Now as the Earth rotates, I am going to spin this Earth counterclockwise. Okay? This yellow shaded area represents the sun's light. So here in North America, we are experiencing daytime. People in Europe and Asia are experiencing daytime. I'm sorry, nighttime for us, daytime for Europe and Asia. So as we spin, it's spinning counterclockwise. It's spinning towards the east. So if you look at our east coast right here, here's Florida, here's our east coast. It is the east coast that experiences sunrise before we do in Texas. Okay? As the Earth continues to spin, if this is us right here, now Texas has experienced sunrise, and finally our west coast. So now it's daylight, it's daytime for our entire country. This is midday, noon, lunchtime. Now as we keep rotating and leave this shaded area, that means that we are going towards sunset. We're going to nighttime again. So the sun is setting along the east coast in New York, Florida. The sun is now setting in Texas, and the sun is about to set in California. Okay? So this entire rotation takes 24 hours. Basically, if you're looking at us, it would be sunset, nighttime, sunrise, and middle of the day, noon. Alright, so the direction, when looking at it up from above, is counterclockwise. If you are facing the sun, you're experiencing day. If you're not, you're experiencing night. So this would mark sunrise. This point right here would mark sunset. And we kind of started to connect this with our time zones. Okay? Again, the sun sets and rises in New York before it does in Texas, before it does in California. New York is 1 hour ahead of us. California is 2 hours behind us. This is why we have time zones. Not everybody wakes up and experiences sunrise at the same time. So the spin was counterclockwise. Another way of saying it is that the Earth spins eastwards. And this brings up, the popular saying, the sun rises in the east and sets in the west. So, again, the Earth's rotation simpler way of putting it, the Earth spinning on its axis, counterclockwise, responsible for day and night. Okay, now looking at the revolution of the Earth. The revolution is known as the Earth's orbit. It's the path of the Earth around the Sun. This movement takes 365.25 days. This is what we commonly call a year. And this causes seasons. Now let's look at these 0.25 days. So our calendar is 365 days. It's not 365 days and a quarter day or 6 hours. It's 365 days. Now over 4 years, these quarter days add up. And over 4 years, we do add 1 day to the calendar. That's what causes our leap year, February 29th. All right, now looking at it piece by piece, let's say that in this picture, we are looking at our Earth tilted in the northern hemisphere towards the sun. What that means is, as the sun rotates, it's getting more solar radiation from the sun in the northern hemisphere. This causes the northern hemisphere to experience summer. Okay? The first day of summer is known as the summer solstice. This occurs on June 21st, give or take a day. It's the day that has the most daylight hours, meaning the sun will stay up in the sky longer than any other day. The sun will also rise highest in the sky. So the first day of summer is when the northern hemisphere is tilted more towards the sun than any other day of the year. Now, as the Earth orbits, I'm going to show the Earth orbiting behind the sun to kind of show a 3D picture. We do study a 3D universe in 2 dimensions. Now on paper, on a test, you'll see the sun at the Earth up here before it gets here, but keep in mind that we're really talking about going behind your computer and then later coming in front of it. So going from summer to winter, we've looked at a span of 6 months. Now our northern hemisphere is tilted away from the sun. Now in the southern hemisphere, those people would be experiencing summer. For us, it would be winter. We're getting less solar radiation. This is the first day of winter is called the winter solstice, typically December 21st, give or take a day. It has the least daylight hours, and the sun rises to the lowest position in the sky. Okay, and one thing to point out, that it is the opposite for the southern hemisphere. Here, it's our summer. The southern hemisphere is experiencing winter. 6 months later, for us, it's winter. For the southern hemisphere, it is summer. So these dates were known as the solstices. Okay, now in between the solstices, we have what are known as equinoxes, one for fall and one for spring. So the first day of fall or autumn is known as the autumnal equinox. Marks the first day of fall, usually September 22nd. Now keep in mind that really we're talking about the Earth going behind the sun if we're showing a flat orbit, but for the sake of seeing what we're looking at here, I'll put the Earth up here. Okay, it's called an equinox for a couple of reasons. In this picture, we want to understand that both hemispheres are equally facing the sun. It's easier to do if you put it behind the sun and imagine that both hemispheres are equally facing the sun. All right, so daytime hours will equal nighttime hours, and the sun will rise in between the highest point and lowest point in the sky. Now, if we start here, that's summer. Here would be fall. This was winter. And then we end up with the vernal equinox, the first day of spring. March 22nd, again, daytime equals nighttime. The sun, again, will also rise halfway in between the lowest and highest point. Now, keep in mind that this is a two-dimensional picture, and really, we want to show the Earth in front of the sun, like so. You know, if we look at this being winter and show a flat plane orbit, we're showing now the Earth, continuing its revolution, we can see a lot easier in this picture that both hemispheres are equally facing the sun. It's not a matter of one hemisphere being tilted towards or away from the sun. They're getting equal amounts of solar radiation. So on that day, daytime will equal nighttime, and the sun rises halfway in between the highest point and lowest point in the sky. So that takes you through the 4 seasons, and it all comes down to the tilt of the Earth and the Earth's orbit. Okay? Tilted towards the sun, summer. Tilted away from the sun, winter. Okay? All right, putting it all together, going from the summer solstice to the winter solstice, the days get shorter, the sun rises lower in the sky through this portion of the orbit. After the winter solstice, remember the winter solstice is the shortest day of the year, the days get longer and the sun rises higher in the sky. So if you look at the summer solstice, when I say higher in the sky, the sun rises in the east and sets in the west. So at the summer solstice, that sun will be in its highest position. For your spring and fall equinox, it'd be in between the summer solstice, and for the winter solstice, the lowest point in the sky. Now, when it's at the lowest, the sun stays up for a shorter amount of time. When it's at the highest point, the sun stays up longer, causing longer days in the summer and shorter days in the winter. All right, and that will do it.